Next we have Fred Conte from UC Davis, speaking about shellfish sanitation models for national growing area applications.
For over a dozen years, my co-author and I, Basamati, have been working on managing and how to manage closure areas and shellfish growing areas based on fecal coliform bacteria, and those bacteria are the indicator organism for fecal contamination and the potential of the presence of pathogens. Now, we've developed 3 models, sanitation models, that are applicable for managing national shellfish growing areas. But as background, what I'd like to do is review the National Shellfish Sanitation Program regulations that govern growing area waters. I'm hitting the next arrow. Which one do you want? Oh, the down area. There you go.
Okay, so all right.
Just a second. I got it.
Oh, okay.
All right. All right. The NSSP mandates a shutdown of shellfish harvest. Anyway, these are the National Shellfish Sanitation Program model ordinance, and these are the things that govern shellfish sanitation. Mandates the shutdown of shellfish harvest areas if the water quality drops below food safety levels. And for a 5-tube test, the geometric mean of fecal coliform concentration must not exceed 14 most probable number per 100 milliliters, and the estimated 90th percentile of fecal coliform concentration must not exceed 43 mpm per 100 milliliters. Also, no more than 10% of the fecal coliform conservation observations may exceed 43 mpm. Now, this is important for that 5-tube test. This is the 1443 standard, national standard. And at least 30 samples are required to calculate the 90th percentile using systematic random sampling collected on a monthly or bi-monthly basis. Now, these are the NSSP standards for different laboratory tests used to determine the concentration of fecal coliform in water samples. The 5-tube test and the 3-tube test are the most common, but a lot of the agency are moving to the membrane filter test because it gives greater sensitivity. Now, note that the estimated 90th percentile changes with each test used as you move down on that other side. Now, all of these parameters are incorporated on our algorithms and models called Aquarius, Pearl, and Mermaid. Aquarius is designed to evaluate proposed growing area closure rules using raw data sets of fecal coliform concentration and closure parameters such as cumulative rainfall, tide, river flood stage, or river height. For example, one example, after a half-inch rain in 24 hours, harvest for 2 days, the area is closed until the fecal coliform counts will drop. And Pearl uses raw data sets to generate Pearl limits. Now, these Pearl limits are important, and we're going to look into these and discuss them a little later. Now, the third model, Mermaid, uses calculated data sets and generates these Pearl limits. Now, we only use data sets that are maintained by regulatory agencies, and the identical analytical methods in the NSSP regression formulas for geometric mean and estimated 90th percentile that's mandated by the NSSP. However, our models also employ additional non-regression equations to calculate the upper limits of the geometric mean and the upper limits of the estimated 90th percentile. These additions consider sample size, also increase the sensitivity of analysis, and it does reduce error. And the heart of our 3 models are these 3 Pearl formulas, or these Pearl formulas. Now, recently, we merged Aquarius and Pearl into a single application that we renamed Pearl. It is a more powerful application for managing shellfish growing areas and can be demonstrated by this simplistic diagram. Now, starting at the top left, the Pearl algorithm rapidly analyzes raw sanitation data sets to monitor bay conditions over multiple years and plots fecal coliform concentrations by time and magnitude in both tables and scattergrams. Now, if you switch to the bottom left or bottom right, if the results show a closure rule adjustment or that you can change the closure rule, Pearl uses the Aquarius algorithm in a feedback loop to modify, fine-tune, and optimize the closure rule without posing risk to the consumers. Now, essential data used by the models are 1, fecal coliform concentration, and 2, growing area closure rules based upon factors such as accumulative rainfall, river flow, river stage, tide height, and agency closure journals. Now, closure journals are a list of closure periods for specific growing area with closure starting dates and closure duration. A single record in a closure journal includes 6 fields: location, growing area, closure starting date, closure starting time, duration in days, and it has an area for comments if the agency chooses to do so. Now, this is an example scattergram or Pearl scattergram. In this, fecal coliform concentrations are shown on the x-axis and time is shown on the y-axis. In this example, the solid line represents the NSSP 43 mpm per 100 milliliter national standard, and the dashed line represents our new standard for the 5-tube test, which is 26 mpm. Now, the X data points represented the estimated 90th percentile, and the O's represent their upper limits. And each data point represents 30 fecal coliform samples. Now, this is the anatomy of that scattergram. Scattergrams plot fecal coliform concentration points appearing in 3 zones: the true positive, false negative, and true negative zones. The true positive zone is the area above the NSSP 43 limit and is considered contaminated, anything above that. The area between the NSSP limit and the Pearl limit is the false negative zone. Now, we consider this to be contaminated. However, this would still be open by the NSSP regulations. And the area below the Pearl limits is the true negative zone and safe according to the NSSP limit and our Pearl limit. Now, Pearl limits are calculated by sorting the upper limit of estimated 90th percentile coliform concentrations values from the largest to the smallest. Pearl then uses the user-specified NSSP limit to search the sorted list for the first record in which the upper limit of the estimated 90th percentile value is less or equal to the user-specified NSSP limit. Now, once this record is found, Pearl identifies the corresponding 90th percentile value for this record as the Pearl limit, and in our example will be 26 mpm per 100 milliliters. Now, the necessary factors, which I'm not going to go into, it's just a busy slide, are the number of fecal coliform concentration observations, the level of significance used, and the NSSP limit used to determine what test is used, such as the 5-tube test. Now, listed here are the NSSP standards for different laboratory tests to determine the concentration of fecal coliform. It shows the NSSP estimated 90th percentile standards and corresponding Pearl limits based upon calculation from agency data sets. As shown are calculations for the 3 tests and 5 tests, membrane filter tests, restricted values for the 3 and 5 tests. The values appearing with question marks will be verified as agency data sets become available. Now, for a decade, we have analyzed agency data sets employing the 1443 standard from the Pacific Gulf and Atlantic coast and found that they were actually managing the shellfish closures on levels below the national NSSP level. These agencies say that they employ the National 1443 standard, but in fact they are actually closing harvest areas at or below the 826 mpm per 100 milliliter pearl limit. The data exhibited here is from over 1 million records of these 6 states. In all of these states, with over 1 million data points analyzed, 95% of the data points for the estimated 90th percentile values appear below the pearl limit of 26 mpm per 100 milliliters in the true negative zone, and 99.2% of the geometric mean are below the pearl limit of 8 mpm per 100 milliliters. Now, our hypothesis is that these agencies set the closure rules based upon the application of the national standards. However, what happens is illnesses continue to occur. Now, if you run the data sets through Pearl and Aquarius, this principle can be demonstrated. If you tighten the rule that closes the bay for 5 days with cumulative rainfall exceeding 3/4 of an inch in 24 hours, you see a migration of the data points for both the estimated 90th percentile and their upper limits to a lower position on the scattergram. So further tightening of the rule for a closure of 1/2 inch, and you see a continued migration downwards of the data points. We continue the tightening the rule for a 1/4 inch cumulative rainfall, and you'll see all the data points of the estimated 90th percentile, and most of those for the upper limits move below the national standard, and the estimated 90th percentile move below the pearl limit. And this illustration demonstrates what likely happens in the states that use indirect closure rules that we have studied. Now, a third model is called Mermaid. Mermaid was specifically designed to work on calculated data sets where you only are supplied with geometric mean estimated 90th percentile values and operates under the direct rule method. And under this method, fecal coliform concentrations are used directly to establish open and closed status. For example, if the estimated 90th percentile of fecal coliform concentrations exceeds the NSSP limit of 31 mpm per 100 milliliters for a membrane filter test, the area is closed to harvest until the next sampling period shows that the concentrations are below the 31 mpm per 100 milliliter. Now, Mermaid can also handle mixed tests, transitional data sets, such as 3-tube tests to the membrane filter test, identify problem sampling areas during the transition period, and can redefine the boundaries of a shellfish growing area. This partial Mermaid data screen was specifically designed for the Virginia Department of Shellfish Sanitation. It shows the fecal coliform concentrations of over 64,000 water samples and over 2,000 sampling stations located in 103 shellfish growing areas over a period of more than 13 years. The left side holds the original data set from the agency, the right side the Mermaid. Now this scattergram shows the lethal coliform concentration samples collected during the open period from a 14-year period. The pie chart shows the NSSP and Pearl agree in 98% of the analysis, but Mermaid would have closed 12% of the stations during the same time period. They appear in the false negative zone. Now, we are currently analyzing Maryland's shellfish growing areas, which occupy the remaining area of the Chesapeake Bay and the Atlantic side. Now, these sanitation models provide faster and accurate means of shellfish sanitation analysis, provide a science-based rationale to support proposed changes to the NSSP model ordinance. Our published results have demonstrated that many of our shellfish regulatory agencies are already inadvertently managing shellfish growing areas below our pearl limit, not at the NSSP standard. And we therefore have also proposed that future FDA MOUs with other countries importing shellfish products into the U.S. follow the same standards of which our domestic shellfish industries are regulated. This is a list of the refereed journals that we publish the data in. They include engineering journals and sanitation journals. Thank you very much.
Thank you, Fred.